That's what I'm talking about. Let's see. Am I good here? Yes, I am. Where is the B? Q word. All right. So while we're getting some oh oh go. So that's what the issue is. All right, everyone. Welcome back to another fun-filled day of Java and other fun programming stuff. So, while we go ahead and get started, today we will actually be reviewing. Let's see if I can. Okay, good. So, today we will be reviewing chapter 8, Interfaces and Polymorphism. And this is going to be not a complicated class, just definitely one that needs to be paid special attention to. Interfaces and polymorphism specifically, is one of the four big pillars of Java and object-oriented programming. So I highly do recommend that you pay very close attention to this. We'll go ahead and get started right away. So we're just gonna go ahead and hop right into it. Um, just gonna step through the introduction and fairly straightforward. Polymorphism is an object-oriented mechanism that allows for objects of different types to be used in the same way. What does that mean? So polymorphism is essentially allowing you to use it allows objects of different types to be used in the same way. So if you have a class called animal and you have another object that is a child of that class called dog, it allows you to execute specific things the same way. We're going to get into that in a bit, but we will we'll get into that in a bit. Let's just continue. So we've already encountered polymorphism made possible by inheritance when talking about casting with cat, which is your parent class, and house cat, which is your child class. In that case, we stored an object of type house cat in its compatible type cat. We'll take a closer look at how polymorphism might work in our cat-centric app. And if we had a cat owner class here with a private object of cat named pet, then public cat owner, cat pet, this just assigns whatever pet to the cat owner and then feed the cat whatever prepares the cat's meal, and eat. The method feed the cat uses the field pet, which is a type of cat. Since a house cat is a cat via inheritance, it is perfectly acceptable to use an instance of house cat to fill in the pet field. We're going to get into something like a lot less confusing than this in a bit. Um, Actually, you know what? We might as well, because it looks like we touch very lightly on polymorphism, and I want you to really get kind of a feel of what we're referring to here. So we're just going to open up IntelliJ. We're going to close out all of this. And I see we have one viewer. Feel free to drop in the chat and say hi. But for now, we're just going to go ahead and create a new package, and we're going to call this Poly. Okay, so we're going to create a new Java class, and this is just going to be a class called car. Okay, now we don't want to add to get, and car isn't going to be like really a lot. We're just going to do private int manufactured year, private string make and model, and just generate our getters and setters. And we're also going to go ahead and generate our constructor. Okay. So there we have our constructor, there we have our getters and setters. Now we're going to do another piece of information to kind of demonstrate, which is going to be public void rev. And all this will do is just print out room. Simple enough, right? Hey, Will, what's going on? Thank you for joining us. Always glad to have you aboard. So this is our car class, which is the parent class. Now, polymorphism will let us do some more cool stuff with this room. And we're actually going to create another class here. And this one's going to be called hybrid. No, and hybrid will actually extend car. And we're already getting an error here that says, hey, we need to create a constructor matching super. So we're going to go ahead and do that real quick. Actually, I wonder if Intellij is smart enough to do that for us. Okay, fair enough. And honestly, we could have theoretically left that out and not worried about a constructor. Yeah, that works. So go ahead and look through here. So we're going to give hybrid a private int mpg. Yep, a class. And we're just going to leave this as is. So let's go ahead and create another class called sample runner. No. So now we're just going to do some basic runs. We're going to do car my car is equal to new car. Okay. And now we can do my car dot rev. And if we run it, we'll just see that we get room. So part of the whole inheritance thing is, let's say that we do hybrid my lame car equals new hybrid. So if we do my lame car dot rev, we actually end up getting room twice. Okay, so this is where kind of polymorphism comes in. And if you have any questions, Coding with John, cannot recommend them enough. They're that ones that actually kind of help me step through a lot of these. So if you have any questions, definitely go check out that YouTube channel. But what polymorphism essentially lets us do is it lets us do the same thing, that is this .rev, in different ways across classes. So let's say that we wanted hybrid wants to implement rev in a specific way. We can actually do public void rev, and we can print out hum, because hybrids don't really rev, they just kind of run quietly in the background. If you agree with me, great. If you don't, kind of wrong, buddy. I'm sorry. So now let's actually run this again and see what happens. Now, you see how my car dot rev still printed out the vroom, but hybrid my lane car equals new hybrid printed out the hum. That's because it's essentially implementing the same method in a different way as our standard car parent class. The method in the child class overrode the method in the parent class, so you're doing the same thing in a different form. Am I? Does anyone have any questions? Am I losing any of you? Feel free to speak up. All right. So I will monitor chat, but we'll go ahead and continue. Now, one more thing to note is we can actually do this again. So let's do a new class. We're going to call this one American Muscle. Not going to add, and we're going to extend car again. Now, let's say that this one has a private int of MPG burned, and let's just do American Muscle my cool car is equal to a new American Muscle car. And let's do my cool car dot rev. Okay, so if we press play here, get vroom, hum, and vroom. What this is essentially doing is we're taking the base class here of our parent class, and we can theoretically run these. We still have access to all of our manufactured years, our everything essentially here, but we're now using this as a base to make sure that all of our classes have rev, and we're doing the same thing across all of our vehicles. We're just each vehicle is doing it in a different way, and we can do public void rev. And since this is a muscle car, we're going to do room, 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 room. Oops, there goes 20 bucks of gas. So now we come back here to our sample runner and we run it. You'll see that our standard car revs normally, our hybrid hums along, and our American Muscle car revs loudly and wastes 20 bucks of gas with 3 revs. So not ideal, but you kind of understand where we're going. And this is kind of, I'm not going to say this is the consummate use of polymorphism, but it kind of gives you an idea to, oh, we're implementing, we're doing the same thing in a different form from our parent class across all of our children classes. And each method in our child class, each rev is overriding the rev method in our car class. Does that make sense to everyone? And if something doesn't make sense, please feel free to speak up. But that is wouldn't you abstract the car class? Yes, it makes sense. Okay, good. So you wouldn't necessarily abstract the car class because if we did, public, is it public abstract or public abstract class? We came in here. Let's see. We start getting errors here. So make car not abstract. And the reason why we wouldn't necessarily abstract the class, I think abstract classes cannot be initiated. Is that correct? Will, you're in our chat. Let's see. Yeah, so abstract classes cannot be instantiated. So if we made them abstract, we couldn't declare new instances of hybrid or American muscle, essentially. With me so far? Oh, do tell. Drop it in the chat. Let's see. There you go. Does this kind of answer your question, Will? So abstract classes cannot be instantiated, but they can be subclassed. And we're going to get into interfaces in a second. I just kind of wanted to put this in front of you. Method would be just an abstract and it would not have a body, right? So theoretically, yes. I just made this very bare bones to kind of show you how polymorphism would work across different implementations of the same across different child classes of the parent car class. And there is also polymorphism involved with interfaces. So it's not like this is just one piece. It's kind of like they both go hand in hand. And let's see. Oh, I was meaning initiated, not instantiated. My bad. Oh, it's okay. Simple enough. Oh, yeah, we're gonna get into those in a minute. Let's just kind of just continue going for a bit. So let's go ahead and continue into interfaces, which is going to be our next piece of the puzzle that we need to solve here. So interfaces, which is what we're talking about now. An interface is a formal construction within Java. They allow us to create a set of behaviors that a class must fulfill. A Java interface can contain constants, that is static final fields, method signatures, static methods, and default methods. So creating an interface is simple enough. One really useful aspect of using an interface is the ability to specify method signatures. A method signature includes the name, parameter, and return type of a method, but no body. as part of our cat application, let's create a method signature eat as part of our interface feedable. Okay, we can do that. So to create an interface, we'll do a new package called cat, and we'll do a new Java class. We just select interface down here, and we'll call this feedable. Don't add. And actually, I might as well just do this and this. There we go. So all we need to do is just do void eat. Now, one thing to note here is in interfaces, uh, I believe that their methods are always understood to be public and they can't have a body. All right. So let's go ahead and continue the code above. So we needed to use the interface keyword, which we did, keyword. Eat only has a signature. We're not allowed to provide a body for methods defined in interfaces. So if we try to do the same thing up here, you'll see that we already error it out here. And Intellij is smart enough to say, hey, delete the method body, make eat default, or make eat static. So we're just going to delete the method body, and boom, our error goes away. Eat also does not have an access modifier. Interfaces members are always public, and while we may use the public modifier, it's unnecessary. So there's nothing wrong with doing public void. It's just unnecessary. We can always just delete this. Boom. An interface method may not have an access modifier more restrictive than public. The feedable interface itself is declared public, which we can see up here, which means that any other class may use it. We may also leave off public, making the interface package private or usable only within the same package. And the name is indicative of the behavior that the interface is intended to describe. While this is only a convention, most interfaces have names that are adjectives. Whatever you do, use meaningful names. So I could totally do void do something. The issue is when I'm trying to call, or I could do void x, void y. Oh, that's not even void. Lovely. The issue here is that these aren't very descriptive. So if someone saw these in my actual documentations, they'd be like, what is this supposed to be doing? Or if they saw them in my code, they'd honestly be confused. So we're just going to keep eat for now. And I did have another cool sample to show you all that I got from someone else, honestly. But we'll continue. So static methods. A static method in an interface can contain code in the body. However, a static method cannot contain any references to instance properties in other classes. This means that our static methods should only deal with universal behaviors that are not dependent on instance properties, maybe dependent on constants. We'll continue. Default methods. The default method has a body and is fully formed method. It is preceded with the default keyword and may be overridden by classes implementing the interface. So we can do default void something else sout sample. And since we declared this default, it let us go through with no problem. Implementing an interface. The purpose of an interface is to define a contract of behaviors that classes uphold. In doing so, we say that they implement the interface. The syntax for implementation is similar to that for inheritance. Here's how we can use feedable interface with our cat. We just add implements feedable, we override public eat, and we do whatever we want to. Since we've declared that cat implements feedable, we have to provide an implementation for the eat method with the signature just as specified. So if we try to do void eat, we would have to provide int override and public void eat for that. Note that we use an override just as we do when overriding an inherited method in a subclass. Like that situation, using an override when implementing methods defined in an interface will enable the compiler to check your method signature. It does indeed match. You can extend a class and implement an interface at the same time. Theoretically, you can implement as many interfaces as you want. You can only extend one class. As with classes, interfaces define a type that can be used when declaring fields, parameters, and local variables. This allows us to relax the requirement on our code elsewhere, thus making it more extensible and adaptable. If an application is extensible, it's easier for programmers for new capabilities to be added later. So here's how we can modify our cat class, cat owner, private feedable pet, public cat owner, blah, 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 blah. I'm doing a lot of blah, blah, blahs. Let's actually get our hands dirty with this. Let's do a new package. We're going to call this interface sample. Okay. And we're going to do a new Java class. And we're actually going to do an interface here. And we're going to call this multiply. Okay. So no, we're not going to do that. And multiply will essentially be let's scroll up here and see what we can do. So how can we do this? Int get next. We're just going to declare this. Hey, we need you to have a method that's called get next in whatever it is you do with this. Okay, fair enough. Let's go ahead and close these out. And let's do a new Java class. And this one will be called multiply by 2. Oh, space is gonna dislike it. No, we're not adding to get, go away. When we use default interface, does it still require write full method? Can you hear me now? Perfect. All right, so yes, when we use the default interface, does it still require the rightful method and implement under the at override? So yes, when you use the interface, you do need to have the full method written out. Okay, so as you can see here, we implemented multiply and multiply by 2, and it automatically said, hey, you need to implement the methods. We only have the one method, which is get next. So we can do public int get next. And what we can do here is we can do, hey, val equals 0. Actually going to initialize that to be 0. We can do value val plus equals 2 and return val. Okay, so now we're going to do a new Java class, which will be called sample runner. No, don't add sample runner. And here we're actually going to do oh, well, first we need a main. We're going to do sout. I believe he was referring to if you made the method default int getNext instead of int getNext. Well, let's look at default methods. The default method has a body and is fully formed method. It is preceded with a default keyword and may be overridden by classes. So let's see, when we use default interfaces, still require the full method. That's an excellent question. Let me check something real quick. Okay. Let us see. Where is it? Let's see. Hang on, I'm Googling something right now. Oh, that's the wrong one. I believe it does not have to be overridden. Honestly, I'll level with you. I'm looking for something real quick because I saw a reference to this, but I kind of got a little lost. So for now, let's just kind of continue. And one thing that I did notice here is when you guys were talking about overridden, you'll see here we have a small little like up thing. We hover over it, implements method in multiply. So I don't know if we actually have to override that. I can test it out. Yeah, let's test it out. So we'll do multiply. Oh, multiply by 2 sample is equal to a new multiply by 2. And we're going to do system.out.println. And we're going to do sample.getNext. Let's run it. So it actually did pull this out, the 2 out. And you did not have to override getNext. Interesting. Just change the method to default and a class that implements the interface and see if it requires you to override. Okay, well, let's try it. Okay, so let's see. Change the method to default. No, 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 no. Okay, we'll do default int get next. So it already started erroring out here. Add method body. So we'll do get next. We'll add a method body. So why not? Go ahead and copy this. The issue that with this is the fact that val. So remember, when we do int val equals 2, it has to remain default in get next. Oh, in the interface. Yeah, that's what I did. Default int get next in an interface. So there's two issues. There's two reasons why we didn't do this. Number one being we would have to initialize our value, and once that's initialized, since that's static, as we see up here, where is it? No. Where was it? Static methods. Yeah, so we can only have constants. No, yeah, I know that there's a weird lag. So the reason why we wouldn't do this in this particular iteration here is because we would have to define what val is up here because we actually have to provide a body. All multiplication is not by 2. That's number one. And if we started it as 0 and then tried to multiply or do anything to that 0, we could not because it would be static. So that's why we didn't make this default. So I'm actually going to remove this. And let's see, int get next, let's remove that. All right. So here we just have, hey, private int val get 2, 0, and public int get next, val equals plus equals 2, return val. If we do our runner, you'll see that we actually do return 2. And let's do a for int I equals 0, I is less than 10, I plus plus, oh, of course, I plus plus. Okay, now let's try running it. So now we went up to 20. And this is where interfaces come into play. So we definitely want to do get next, and we have a multiplication, which just gets us the next multiplication. So if we're doing by 2s, let's say that we wanted to do another class, new Java class, by multiply by 3, and yeah, we're not adding you, implements multiply, we do private int equals 0. Yeah, I know. And we'll do same thing we did right here, which is public int get next. Public int get next. The only thing, public int get next. So I wonder why. That is weird. So for some reason, it let me do this over here with no issues, but then when I did it over here, it automatically overrode. That is weird. But we'll take the same logic, val plus equals 3, return val. Okay. And now when we go back to our runner, we'll actually declare another one. We'll do multiply by 3, sample 3 is equal to a new multiply by 3. And let's do the same thing. So sample 3 dot get next. Okay. And now when we run it, because any classes that implement an interface has to have an override has to override the methods. So yeah, what I'm saying is it's kind of weird that here IntelliJ automatically added it, but in multiply 2 it didn't. See what happens if we add it. Maybe it's implied, but as you can see, we have, well, let's make this a little more explicit. So I twos, and then by threes. And now let's run it. So as you can see, we implemented our interfaces. We implemented the bodies that were needed for these two, which each one has its own get next, and each one is just adding 2 to the value. And IntelliJ is smart enough to go, hey, get next for sample is different than get next for sample 3 since they're different objects. Does anyone have any questions on this so far? Okay, I see. So no questions before we continue? Okay. And let's just try something else. Let's do this. Let's actually go back into our multiply.java, and we are going to declare 2 new pieces. We're going to declare, and these are going to be static, int, oh, too high, int max equals 10. And we're going to declare string error message equals cannot go above the max cap. Okay, so one thing to note on these is, where is it? So these can be called from anywhere. So, well, anything that implements this. So let's actually go here into our by 2, and we're going to do if val greater than or equal to max. And since max is a public static integer, we can call that from wherever. Same with error message. Well, except instead of an integer, it's a string, I guess. So if val is greater than or equal to max, we'll do print out the error message, else return 2. So now we have, hey, if the value exceeds 10, which we already know max is a constant essentially, we'll print out the error message, else add by 2. Okay, and let's just go ahead and run this. Do I still have audio, by the way? I do. Okay, good. So now if we go back to our runner and run this, you'll see that 2, 4, 6, 8, 10. But once we try to go above the max cap, this started erroring out saying, hey, can't do that. And theoretically, if we wanted to run this in threes, we could do the exact same thing. So we'll do this, copy, we'll do this, paste, except we're going to change this to 3. And we're going to run our sample runner. So 3, 6, 9, 12, 10 by 3s went to 12. Interesting. So 3s continue to go past max. No, by 2s, by 3s went to 12. Oh no, it just kept repeating the same error message. Okay, that's fine. So our 2s never went to 12. Our 3s made it up to 12, but that's just because that was the last value before it had hit our limit, and we still returned it. So that's how we can still use our constant max of 10 to theoretically bump this up to 12. And if we run this again, 2s and 3s get capped at 12. And yeah. So I know that that was kind of like a disjointed version slash breakdown of interfaces. It's just kind of hard to really get your head around it without really taking a much deeper dive than you probably want to. But we did touch upon creating our method signatures. We did touch upon, hey, whatever method signature we have here, like int get next, is the same one that we have to have here, int get next. The only thing that we did different here is we declared public, whereas here in multiply, public is just understood in our interface. Same for over here. Let's continue. We did declare the interface itself public. The name is indicative of the behavior that the interface is describing. And we're being swarmed by Russian bots. I love it. And a default method has a body and is a fully formed method. Let's Google something. Actually, let's do this. Let's see. Okay, so we're going to do a default method, I guess. So default void print a message, which is South math is fun, ha ha ha. Okay, so as you can see, here we're fine. We have absolutely no issues, even though we did declare the void method. And if we go to, where is it? So default void print message default has a method and is fully formed. It is preceded with the default keyword and may be overridden by classes that implement it. So let's just try running it, see what happens. Let's do sample dot print a message. And you'll see how here we automatically get an error. And chat, let me know if, ha ha ha, yes. So let me know if, so we automatically got an error here. If we look through our error, we got it because, fairly certain it's because print a message cannot be applied to void. So let's just go ahead and delete that. And okay, that worked. Oh, go. Let's run it. Void type not allowed here. Oh, the fun stuff we do here. Oh, no, we actually needed that. Do sample dot print a message, and let's run it. And we did get math is fun, ha ha ha. So that method was already there, its body was already established, and we called it because it was implemented in our interface. No issues there currently, but we can override this. So let's say that we wanted to do a different one. We wanted to do public void, and we called it print a message. Let me check something in my notes real quick. Let's see. Okay. So public void print, we called it print a message. And we're just gonna say this is the multiply by 2 class. And you see how we have this like up arrow right here, overrides method and multiply. So it's acknowledging that it is overriding a method. We do need to keep public void. And we can do the add override, but I don't think we need it. So let's try running it now. This is the multiply by 2 class. And just for the heck of it, let me try removing the override and see if that changes anything. So it looks like it's understood to be overridden, but honestly, it's kind of hard to tell where exactly we land because Intellij does a lot of cool stuff for you on the back end. It just does it without exactly telling you what it's doing. Before we proceed, do we have any questions, comments, or concerns? Oh, right. Let's do this. Yeah. There you go. Does that help? There you go. Okay. All right. So, perfect. We've already implemented our interface, as we can see here. Since we've declared that cat implements feedable, we have to provide an implementation for the eat method. And we did something similar here with get next for multiply. Do you guys want me to do the cat class as well? Or is the multiply class good? Question mark. Okay. So yeah, the way that they would want to do, cat would implement feedable. You would have to override the public void eat, which in our case was public int get next. They did use that at override when overriding an inherited method in a subclass, the same way. Like that situation, using at override when implementing methods defined in an interface will enable the compiler to check your method signature does indeed match the interface. You can extend a class or implement an interface at the same time. And you can technically implement multiple interfaces. You would just do implement multiply, comma, multiply 2. Okay, Will's good. Mika, do you need me to go through the other one, or? And this is how you just implement multiple interfaces at the same time. Like if I did, let's do a new class interface sample 2. That's true. Yeah. So theoretically, you could come here into your not the sample runner here, and also implement sample 2, and your syntax does allow you just separate them with a comma. Okay. As with classes, interfaces define a type that can be used when declaring fields, parameters, and local variables. This allows the requirements on our code us to relax requirements on our code elsewhere. Now that we've declared the property pet of type to be of type feedable, this class assumes that only behavior of pet will need within the class is the ability to eat. Okay. I don't know if we actually have to go through here, so I'm just going to kind of hit the highlights. The opportunities for using the classes we've built are much wider since the defined classes are no longer dependent on the specific cat class. So here we're no longer dependent on, I guess, the multiply class. As we've noticed, we've used the object Suki in a polymorphic way, creating it as a house cat, but using it as a feedable with a cat owner. Like inheritance, interfaces enable polymorphic usage of objects. We can create an object and then use it in different contexts based on the interfaces that implement it. Interfaces may not be created like objects with new. You may implement an interface or declare variables and parameters as interface types. You cannot, however, create an instance of an interface. So we do have here we implement our multiply, but nowhere here do we see multiply 2 equals new multiply. We just do this to inherit the need for get next, and then when we actually do our Java runner, we have multiply 2 sample equals new multiply. So a couple of benefits of using interfaces. Once we get used to using interface, we'll begin to think more abstractly about which behaviors your code requires instead of which classes your code requires. That means you'll be able to code to interfaces and OOP principle instead of coding to classes, and your code will become more flexible. A few benefits: you can only extend one class, but you may implement many interfaces. You can extend a class and implement an interface at the same time. By declaring variables and parameters as interface types, you make your code useful for a much wider variety of situations. When you declare properties and return types to the interface types, you decouple code using your class from the actual class types you use. This means you're free to change the specific implementation of your classes without affecting the usage as well. Remember that we don't need to start creating interfaces to use their power. We'll cover in later chapters when working with collections. We can declare variables and parameters to be interface types if we only need to use specific behaviors. Okay, so check our understanding. Choose an appropriate option to fill in the blanks. A class can extend blank class and implement blank interfaces. This is B. A class can extend one class and implement more than one interface. True or false, an interface can contain a static variable, a final variable, and a static final variable. I want to say that this is false because an interface can only contain, as we see up here, constants, which is static final. So that would be false. And which keywords are missing from the following interface? Public, temperature, double final absolute 0, and double convert temp. If we scroll up, we can see here we're missing public interface temperature, right? You're correct, Wilbert. Good stuff. Okay, now we're going to go into interfaces and abstract classes, which thankfully our reading here is light because we've already hit the hour mark. So We mentioned previously that interfaces share some characteristics with abstract classes, to your point, Wilbert. Recall that an abstract class is one declared with the abstract keyword. You may not create an object from an abstract class, and like an interface, an abstract class is allowed to contain methods that only have signatures. That is, they don't have implementation codes. The main differences between interfaces and abstract classes are, number one, you implement an interface and you extend a class. The net effect of this is that a class may implement interfaces while also extending a class, but you can implement more than one interface. You can only extend one class. Simple enough. Abstract classes may contain non-constant fields, while interfaces can only contain constants. And interfaces may only contain implementation code inside of default or static methods. Therefore, interfaces can't contain methods that need to be shared by class instances in the same way that abstract classes do. In particular, any method that needs to use an instance property may not be part of an interface, since the interfaces don't have instance properties. Unlike interface, abstract classes may have methods which are not static or default and which do have instance properties. We should use abstract classes to collect and specify behavior by related class, while we use interface to specify related behaviors that may be common across unrelated classes. So let's go back to our feedable interface. If we want to add dog to class to our application, we might implement the feedable interface for our dog class. That makes sense as dogs are creatures that we feed. However, as dogs and cats are so different, it is unlikely that they would share so many behaviors through the pet class. Yeah, that's fair. Question. Check all the statements that are true about the differences between interfaces and abstract classes. You can extend an abstract class, but implement an interface. You can implement many interfaces and many classes. That one's false. Interfaces cannot contain non-constant fields, but abstract classes can. That one's true. Methods that use instance properties can be in both interfaces and abstract classes. So, what do you all think? There's two to my knowledge. Good catch, A and C. All right. I'm going to just continue to breeze through. So there's a couple of situations where we'll want to use interfaces, involve applying predefined interfaces and classes that are part of Java, and comparable in order to allow comparison. Good stuff, Mika. So I'm not going to go through these just because there is a lot here. If anyone is very interested in actually seeing me go through these and how they're implemented, I'll probably do that in another video. Just because you can read we could read the documentation online, but as you can see, it's kind of massive. So you have comparable, comparator, which compares two objects of a given class. This interface can be used to determine, given two objects of that given type, which one is greater than the other. Can also be used by collections such as an array list or to sort its contents with a sort. You have iterable, which enables iteration over a collection of objects using a for each loop. A list, which enables access to the objects in a collection by index. A map, which is a key value pair. And okay, so check your understanding, true or false. An interface can extend another interface. What do you all think? So that is true, actually. An interface can definitely extend another interface. And I wish it was a solid. So see if there's a solid sample. Oh, good God, this is definitely unique. So I wanted to give you all a sample of this, but holy, this is different. So an interface can extend multiple interfaces in Java. Here you have interface A, which is test and test one, interface B, which is test and test two, interface C, which extends A and B, which is test three, and class D, which implements C. And here they just public void test, testing N, testing one, testing two, testing three, and oof, it definitely worked. So I don't know why you would do this, but I'm fairly certain there's some niche scenario where you would want to. Uh, I honestly don't know why you would want to implement multiple interfaces. I'm assuming it's just when you're working with something extremely complex that required a lot of specific implementations, you would want to do that. Yeah, tell me about it. All right. Mika, list extends iterable. Let's check it out. Huh. Okay, so you're technically right. No, you're correct. What's up, Will? What's your question? Yes, as many as you want slash need, but I feel like the need would be rather niche, just depending on what you find. And you can implement the iterable interface. Here you have private class person implements iterable, and here you have a private list person as new array list. Yeah, so that works. What's up, Will? What do you got? There's a weird lag here. All right, I'm gonna go ahead and continue. Will, once your question hits the chat, I will oh, the others give an example of implementation, but compare and comparator. How would you use them? Let's see. Let's see. Iterable collection is new array list. Yeah, so you can actually click on the documentation, and if you scroll down, let's see. There should be a sample here. Um, oh, no. Okay. Comparator. No, it doesn't. That's weird. Shouldn't. So yeah, comparable and comparator would essentially be used the same way as here. String iterable string collection equals blah blah blah. List string collection is new array list. Map string string collection is new string. So let's actually see if we can find one of those. Let's see. Java comparator example. And yeah, public int compare, go away. Yeah, you would have a class of students, int roll number, string name address, public student int roll number, string name, string address, string to string, which just overrides the toString method. Then class sort by role implements a comparator of type student. And here you can do public int compare student A, student B, and return A dot roll number minus B roll number. Or here you can do class sort by name implements comparator for the student object, and then public int compare student A, student B, return A dot name dot compare to B dot name. So there's a couple of ways to do this, but if you see, where is it? Collections.ar sort by name. There's a couple of ways you can do it here. Does this kind of help answer your question? And that's for comparator. Let's get you comparable. Oh, I wonder, actually. Um, where is Geeks for Geeks? We only like Geeks for Geeks. Okay. And here is class movie implements comparable movie. And remember, comparable is essentially just letting you know, hey, there's this and there's this. You kind of have to write that in as it's an interface. So here you would declare a rating, a name, a year. You would do a compare to movie type object named M, and then compare the this year minus that year, public movie string, and M double RT int year. This is your constructor for accessing information, etc. So let me drop these in chat for you. That's for comparable. Definitely check it out. Okay. And so basically you implement it and then you use, for example, the suggested important methods. You can do that. You can also tweak them to do whatever it is you need them to do. So if you and comparable or comparator would tell you, hey, you can compare based off of specific, like compare parameter 01, parameter 2 compares its two arguments for order, or you can do a Boolean to see if it's equal to this comparator. And the documentation will definitely help you out a lot with this. So let's just continue. And unit testing on interfaces. After all that we have learned about interfaces, you're probably wondering, how do I write my unit test for interfaces? The best practice to testing interface are very similar to testing inheritance. You want to focus on testing the contract that the interface is supposed to be upholding as opposed to the interface itself. So if we have a temperature interface, a Celsius class, and a Fahrenheit class, you have your public interface temperature, you define absolute zero, and you need a double convert temp. You have a public class Celsius that implements temperature. You have a private double current temperature, and then you override convert temp to convert it to Celsius. Same thing, you override to convert to Fahrenheit. In this situation, we can test the contract that the interface is supposed to be upholding, but not the interface itself. We can choose to test that absolute zero is negative 273.15 for both Fahrenheit and Celsius. We may also want to test that the convert temp function works as expected. However, since convert temp has a different method body depending on whether it's Fahrenheit or Celsius, we cannot define that as expected behavior with a test on our interface temperature. So you would not necessarily want to verify that your convert temperature works the exact same way, but you could verify that it exists in there, that it's working as expected, and that absolute zero or your constant is there across the board. True or false, you should test the interface itself. correct answer is the correct answer is false. You are correct. So you wouldn't want to test the interface itself. You would just want to test that certain pieces of it and the overall structure, the overall constants, and the overall requirements are there. So yeah, kind of a gray area where you kind of do but kind of don't. And with that being said, we have reached the end of our talk for today. I will be posting the exercises sometime tomorrow. So if you have any questions or concerns, please feel free to drop them in chat. Slack me directly. I'm always more than happy to help anyone out. And I will definitely see you at the next one. Stay safe. Have a great evening. And we'll talk then.